Okay, so page 98, number 13. The mass of an elevator is 4,850 kilograms. This elevator should be designed to have a maximum acceleration of 0.0680 Gs, or 0.0680 times 9.80 meters per second squared. And just out of curiosity, what is this acceleration? What's just that number, 0.0680 times 9.80 meters per second?
0.6664.
0.6664 meters per second squared. Okay, here's the important question, which you have to think about first, and which the first time I looked at this problem, I completely failed to think about. If the elevator is just hanging there, doing nothing, how much force is on that cable? Gravity. So the minimum force, just to sit still, this elevator has to, cable or motor, has to deal with 4,850 kilograms being pulled down to the center of the earth at 9.80 meters per second squared. And what is that amount?
It's over 9,000.
Yes, and I think, Jake, this might be where your other numbers were coming from. So what's this going to be?
47,530.
47,530 newtons, correct? Does that make sense?
Yeah.
That's a minimum force this thing should be able to handle. That's just to hang there. And an elevator that just hangs there is of seriously limited use. Okay? Now, let's say in addition to overcoming gravity, we would also like this elevator to go up an additional 0.6664 meters per second squared. Then I have to add that acceleration on top of what it's already doing with gravity and get another larger number. So I have to add 0.6664 meters per second squared to the gravitational acceleration, which everything is dealing with just by standing still, in order to find out how many newtons of force are necessary to get this thing to actually move upward. 50,762 newtons.
Yeah.
Now it also...
That's what I said.
Yes. I heard 5, I didn't hear 50. But yeah, so that's your total number. Now they also said a minimum acceleration. I don't know enough about motors why you would care about a minimum acceleration. I'd imagine 0 would be fine. But if you want to know a minimum, and I can't imagine that there's a minimum force, but this is not, there may be something to do with like the gear ratio and a couple other things. I know with cars you don't want to go below a certain speed sometimes. But this is not the least amount of force, at least, that this should deal with.
Shouldn't it be like the 9.8 minus?
If you want to talk about, yeah, now this question's phrased a little differently, but just, if you want to talk about the minimum tension on the cable, maybe it's a rubber cable and it'll snap up if it doesn't have a certain amount of tension on it. But remember, like we talked about yesterday with the person sliding down the sheets 2 days ago, when the elevator is going down at its maximum acceleration, I'm assuming it's the same acceleration because they don't mention direction here, you would subtract this from 9.80, and then what's the minimum you'd have to deal with?
44,297.
44,297 newtons. Awesome. So we have hanging still, maximum acceleration upwards, minimum when it's accelerating downwards. At University of Maryland, I performed on a gymnastics troupe. I was in an act that did handstands on towers of chairs and such things, and we would try to improve our handstands by going to a 9-story dormitory building, kicking up to a handstand in the elevator before anyone hit the button, and holding the handstand while someone hit the button for the elevator to go up 9 stories, which is a fairly long time to hold the handstand. But at the beginning, your weight increases because the elevator starts accelerating upward, and your actual weight increases while you're in the handstand. At the top, your weight decreases as the elevator decelerates. Just out of curiosity, and this has nothing to do with the physics we've studied, which do you think is harder or to hold the handstand or more unsettling, when your weight suddenly increases or when it suddenly decreases?
Decreases.
Yeah, decreases was much harder. Increases, you just tense up and you're like, you got something to fight. When your weight suddenly decreases and you're upside down, that's a weird feeling.
It's like, you almost like, whew.
Yeah, it's where'd the floor go? It's good exercise. Yes?
I know this doesn't really have to do with what we are.
Okay, then can you hold it while we're recording that and we'll come back to it? I want to hear it at the end. Okay, that's number 13. Have we gone over 12 and 11?
Yeah.
Nope.
12 sounds familiar. 12 looks like we covered. What about, did we do 11?
When would we have gone over?
I'm not sure. I guess we didn't. It looked familiar. Any questions on this one? Going once? Going twice? Okay. And remind me to edit it. Actually, Robbie, go ahead and stop it real quick.